I mean, we can start with the
Yeah.
intro otherwise, I would say, to not waste time. Okay, so while we sort out the slides, welcome everyone. This is room 7. Our talk is Lukma No Metrics, our quest to extracting SLOs. My name is Patrick Bänziger. I'm a customer reliability engineer at Swisscom now for a bit more than 2 years. I have a background in software engineering, also a Java engineer. And my colleague is Stefano Taillefert. He's a site reliability engineer, also at Swisscom since the start of this year, so very early on already here at the conference. So I hope in this bite-sized talk, after you had a bite for lunch, hopefully, we're able to kind of give you... now we have the slides as well. Excellent. We can tell you what we do and why we do it, and how about we extract SLOs. So reliability management, that's the area we are working in. And you all probably know about the importance of reliability for an application. You know that nowadays people, end users, expect their application to be up almost 24/7, and all the unique challenges that brings. It means that for customers to be happy, they need to have a reliable system. And that's actually the area we are working on. And if you always check out the QR codes at the top, you can learn more about these topics. We are working in the site reliability engineering as a service offering in Swisscom. And there we really try to assist our customers, so companies, to improve the reliability of their product, of their services, so that the end customer has a reliable system and can use the app or service at all times. And I'd like to give you one example of these kind of engagements, one that you're probably familiar with, even though you don't know it. And that one is the Swisscom Twint White Label Services. So you probably all know, and I need to kind of give a small disclaimer, you probably all know Twint, the payment solution offered by Twint AG. This is not quite about that, but it's about the Swisscom Twint White Label Services. That is an offering by Swisscom for banks in Switzerland, so that they can offer their customers a Twint payment solution, which then integrates into whole Twint payment ecosystem. And for them, it's easy to do so because all this kind of infrastructure is handled on Swisscom side, and then the end customer gets a styled app in the design of their bank, where they can directly pay with their bank account without having to resort to a credit card or prepaid. And almost all banks that are offering that in Switzerland are actually using this Twint White Label service by Swisscom. So a majority of all transactions is actually running over that service, which also means this is a high-stakes service. If there is an incident, if there is an outage, people notice, and you see that trending on social media very quickly, or have bad press. So obviously, we would like happy users, but how do we actually measure that? How can we make sure users are happy? How can we then improve if they are not? And those of you who are familiar with the concept of site reliability engineering, they know these kind of concepts that I'm going to show here as a quick repetition for those who don't. The popular Google books on site reliability engineering, they tell us about so-called service level indicators. If you define those well, they are a measurable analogy of user happiness. And that means if such an SLI is bad, your users are probably not happy. Of course, if they are good, there still might be other reasons that your users are not happy, but it should not be this technical reason. For example, here, if we take a web server, a possible SLI could be how many requests, what fraction of them were successfully responded. So of course, a happy user means a high number of those requests, a high success rate, and a low success rate will mean unhappy users. And then you need to define where are the users going to be unhappy, because you can't reach 100% success rate. That's just not achievable. So you need to define an SLO, a service level objective. And that SLO should be a target value with a measurement period. For example, you would like over a month, 99% of all the valid requests to be successful. And additionally, that should be at a level, when you meet that, of course, users are happy, and it should be below your SLA, if you have any. Now, that's nice, but how do you actually now get value out of this? You can define that, and you can now define those SLIs, and something happens, and then profit, right? So what's in that box there? So what's the usual assumption here is you need to instrument your application. You need to have some metrics, like what I said, was this successfully responded to or not? And then you need to collect those and calculate your SLI, and then you profit, right? Now you can, when you have that calculated, you can measure, you can alert on that, you can improve that. But there are some fun assumptions in here. There's an assumption that you can change the code to instrument it. In a large company or in general, you might have a piece of software that is a third-party software, proprietary software that you cannot change. It's also an assumption that you can change that. Even if it isn't, that piece of code might be developed by another team. You're just responsible for operations, so you'll need coordination. And even if you can change it and you can change it, you might not be able to change it now, because it's usually sometimes requires to integrate not just a library, but also add some code, and it just might not be a priority. And similarly, for us, that is also the case. Twin white label services, they really put much focus and much effort on improving reliability, but we didn't have the time to instrument the application. But we still wanted to get the value out of these SLIs. So Stefano, please tell me, how could we do that?
Well, at some point, we had an idea. What if we tried to derive the data that we need, that we would usually get as metrics, from the logs of the application? As many other applications, this twin white label service backend had some logging going on. And from there, everything that is tied to transactions was recorded, whether it was successful or not. So as a stepping stone, we thought we could collect these logs from the central place where they would be stored. And of course, this being a banking application, what matters the most is the user transactions. So those are the key user journey and the key component that we want to check for failures. If you're stuck at your Coop or Migros cashier and you can't pay, there's probably a problem. So that's what's important for us. And therefore, we can reach this definition of our SLI, our indicator, as the success rate, meaning this is the proportion between the successful transactions over the valid transactions. Valid transactions means that there are some errors, like business errors. For example, your account doesn't have enough money, or the user, the destination user doesn't exist. We decided to ignore those because those don't indicate a failure. And once we have this indicator, then we can define our objective. For example, as we said, in a defined period of time, over a month, we can have, for example, 99.whatever% success rate. That's what we came up with. And to recap our architecture from a system point of view, we have this existing solution, which was the Twin white label application with this banking integration layer, which would handle all the finance part. And usually we would scrape our metrics directly from the backend that we instrumented, but that's exactly what we couldn't do. So instead of doing that, we took the long way around and we deployed this log exporter, which would fire some predefined queries against the log aggregation instance and expose those metrics that we needed. And so we got to what we needed. And as far as it is often, We weren't the first ones to think about that. There's some existing solutions, some exporters, some adapters that you can find on the internet, depending on how much, what your logs are stored into. It's a matter of finding the right tool for the job. We didn't test all of those. We're good, right? We have our metrics, we have what we need, we have defined the SLI, SLO, but as it happens often, we had some problems. For example, our exporter did fire too many queries because we couldn't get all the data at once. We had to do 2 queries per bank. And there's a lot of banks. I mean, Switzerland is famous for that, right? So that was too many requests. Our colleagues from Twint White Label were kind of pissed at us because we bombarded them with requests. And so we had to aggregate some data to tone it down a bit. Also, our queries at some point were misaligned because we used sliding windows. And so we would end up with some funny stuff like more than 100% success rate, which doesn't look very professional as a statistic. And last but not least, we also had some stability problems, meaning our exporter would crash if the log aggregation solution would close the connection for whatever reason. And so we end up losing data over a period of time. That was also not ideal. We fixed some of those. We are working on a new version of the exporter. And I don't know, maybe next year we'll be here again telling you how that went. So let's check out a quick demo of what we ended up with. We are gonna see a dashboard from one of our live production systems. And so we can show you the data we ended up having. Thank you very much. So this is your kind of classic Grafana dashboard. Here we can see, as I said, live data from production. This is over the span of 7 days, over a week. And this is the total transactions that happened. You can see in these valleys here, those are the nights. And then at morning, there's the people start to travel, traffic ramps up. And then this is the lunch break peak, which is probably the hottest moment in all the application life, meaning everybody is paying and it's a very short period of time. So that's always the critical phase. And then it always goes down a bit. You have the apero peak here around 18, kind of. And then it goes back down at night. You can easily spot the weekend here, some Saturday shopping, etc. And with this, we also defined our success rate, which is, you can see it's very sensible at night because there's less transactions, of course. So it potentially could wake you up at night for nothing as well. But this is pretty good. I mean, we can alert on this. If something fails, then we can spot immediately the problem. But there's a lot of buts. But if you have, for example, a load balancer that fails and you only get half the traffic, you get half the transactions, but all of those are successful. So this wouldn't detect such failure. And for that, we deployed some additional stuff. As you can see in this bluish range, this is anomaly detection range, meaning this kind of predicts, not always optimally, let's say, the amount of total transactions for these days based on previous data. And therefore, if we have less transactions than usual, the value falls outside of the predicted range, and we get an alert for that as well. So that covers also this case. It's not perfect, but it gives us yet another way of measuring if something goes wrong. And to quickly show, to quickly mention about this anomaly detection, it's very simple. There's no big complex algorithm or expensive machine learning solution. No. We do things simple. We take the data of the last week, that's 2 weeks ago, 3 weeks ago, and 28 days ago to better account for the month rollover. And we calculate some basic statistic like mean and standard deviation. Then we factor some growth over the weeks, and then define a margin. In our case, plus minus 3 times standard deviation. This is a factor that you have to adjust. And so, as I said, this is not really complicated, but this gives us this prediction thing. Of course, being simple also means that there's some limitations like holidays or special events like Black Friday, because it doesn't know the calendar. That's all I had to share. Back to you, Patrick.
Thank you, Stefano. So yeah, our key takeaways, basically, what did we learn here? We learned you always have logs, right? And you can use those logs as a stepping stone. They can give you very quick some value that you can use in these kind of calculations. Even if you don't have a log aggregation solution, you can use one of those sidecar patterns, for example. They do have the downside of being architecturally brittle, right? If you change that line of logs you were matching on, your queries won't work anymore, right? So they are a good intermediate solution that you can build on. And they actually sell. So demonstrating this small increment of value helped us to convince the customer, hey, look, this is really good. You should instrument your application to make this more stable and also add more value with business metrics, right? You can use those to sell. And the third one we've really figured out, and I want to give a shout out to the article from GitLab that showed how you can do these kind of predictions with built-in functions of Prometheus. Prediction is not that hard. You can do that yourself. And I truly recommend try it out. Try some anomaly detection. It's really not that simple. But yeah, so even if you don't have metrics, don't despair. Just look at your logs and derive some value from that. That's it. Thanks. Still, if we have time for Q&A, we
can see the hands with all the lights. So.
By the way, we also do have references and the slide QR code here if you want to check out, and you can click then on the slides.
Yeah, so thanks for your presentation. So my question is, do you gather those logs from bank system logs or your own systems?
Thanks for the question. In this situation, it's actually a distributed system. So there's banks involved in all, and we are actually gathering here multiple sources. It's still not from the bank customer. It's still limited at our company boundaries, but we do have the integration layer, the banking integration, and the twin white label application, and we use those two. So you can also do cross correlation a bit there.
Okay, and do you have any moments where you realize that there are some things failing, but there is no log line for it?
Yes, there are cases, of course, especially if what Stefano said, what we try to do a bit with anomaly detection, right? If it fails at a stage before that it reaches you, where you have no logs for. The typical case is if there's a WAF, or if there is in the authentication solution, that is a problem, right? And that we also did see that if it fails before, then you don't see it in the logs. That's what we kind of then use the anomaly detection for.
Yeah, thank you.
Thanks.
Hi guys, thanks a lot for the presentation. It was really interesting. With regards to the two approaches, so instrument your code and log to metrics adapter, do you think that one excludes the other? Would you say if I cannot do instrumentation, I should go for logmet? That's clear. But if I do logmets, can I also instrument?
Yeah. Yes, I mean, yes, you can. It could really be if your logs are stable enough, if you can get value out of them, that might be a faster way. Depending on your release schedule, how fast you can change that, integrate that. You could already get value now out of the logs, and still have time to build it properly or wait for whatever instrumentation you have. So you could use them as a stepping stone. You might also have a kind of hybrid deployment where you can instrument some parts and others you can't. So you can still use the log approach for those you cannot change, but still use the instrumentation ones for those you can.
But on the long run, you envision like
Uh,
time and budget on instrumentation.
I would recommend, if you can and have the budget and time, do the instrumentation, because it will be more stable and you will not be it will not break when someone changes the format of your logging lines, right? Yes.
Thanks a lot.
Thank you.
Yeah, a quick question.
Do you also do some cross verification, validation of the data between Twint and the bank, for example? So if you see a transaction, you use the Twint or the bank or both. If you see one transaction in one feed, not in the other.
Yeah, so if we kind of detect if we lose transactions somewhere in between. Not in our case right now, because of course there's also you need access to both systems, both log systems, from the banks itself and from us, and then also need to kind of be able to have a correlation identifier. So not yet, but it's an interesting proposition.
Thank you.
Thanks.
Okay, so time is over. So thank you very much, Stefano and Patrick.
Thanks everyone for coming.
Thank you.